In the methodology, we have mentioned that we will be using Google Colab. So we are using Google Colab here. At first, go to Google, then search Colab. Go to the first link. Then this pop-up will be appear automatically. So go to the upload, then browse and select the software file from here. Select the IPYNB file. It will be upload. So we have uploaded our software file, Python file here. So now go to the connect option and click on connect. So we have to at first connect the kernel here. After then we can use our Python environment. So it will take some time. Okay, it's done. Now go to this file section and click on this upload section and choose the dataset file from here. You can download the dataset file from the given link on the methodology data collection section, or I can send you the dataset file along with this video. So our dataset file is uploaded here. So we can run the code now. Okay. So just click on the cell and paste, shift and enter together. This way you can run all of the cells one by one like this. You have to press together, shift and this. So as I have already run the code, so just I am going to just explain the code step by step. So at first, in the import code library section, we have to import all of the libraries that we are going to use in the upcoming sections. Like we have to use PD. Just like we have uploaded a library named PD, so we have used the PD for dataset loading into the Python environment. So in the same way, all of these libraries have different works, and that will be used in the upcoming sections. So this section is also for also the same thing, and in this section we have used some warnings. Sometimes Python give us some minimal type of warnings, so the code looks very messy. To avoid that, we have used this section, the import warning, nothing else. Okay. So on the load and preview dataset section, we have at first loaded our dataset here. Like we can change this, we can change this path just by clicking on copy path, and we can just paste the new path inside this. If you have uh, any kind of error in this section, so you can just do this. Then no error will be here. Then we have uploaded our dataset here, and at first we have dropped these two columns as we don't need these two columns, and we have then showed the data head. The data head is the first five rows of our dataset. Like here is the first five rows of the dataset, 0 to here. All of the remaining columns are there. Then this section is about the dataset information. We have used df info function to visualize the data information, like which column is of which data types. Like packet size is a integer type variable, then response time is a float, like this. And totally we have our in our data set we have 2000 rows, I mean 2000 entries, and total column is here 15 columns. Then this is descriptive statistics, like which column have the highest value, which column no, like the which in any particular column, which value is the maximum value, which value is the lowest value, the mean value, and STD means here the standard deviation value, and these three are here percentile values like 25%, 50%, and 75%. So, like from here, we can say that in the pocket size, there are total count of rows is 2000 and the mean value is 800. And here, the minimum value is 64 and the maximum value is 1499. Just this. And there are some, then there are some non-numeric data in our data set, like here in the attack level, we have these attack types like normal or attack. So we have to just convert them into 0 or 1, like in non-numeric, so that in the time of machine learning model training, we can use the data perfect. So we have used this. Then we have checked our null value. If there is any null value, then this section will drop in null value. Then we have used the scalar. In the scalar also, we have converted the attack level data in numeric data. So then we have our fast plot, like these plot are called EDA plot, exploratory data analysis plots. So in the first plot, we can see comparison between attack versus normal traffic. Like in our data set, the attack count is about 600, and the normal traffic count is approximately 1400. And in the second figure, here is our correlation between features. So all of the feature column in our data set, we have uh, visualizes a confusion matrix. So this is a correlation plot, and this is the confusion matrix, and we can see a range, like if it's totally red, then the value correlation value is one. If it's blue or light blue, then the value red. Then we have our different types of protocol. We have our protocol like these types of protocol. Packet size for normal versus attack data. This normal versus attack data. There is the correlation, like packet size is 1400. The attack level is, as we have converted the attack types as numeric data. So 0 is normal and 1 is attack data. Here is the distribution. Then we have our entropy distribution for normal and attack. Like the blue represents the normal, and the orange represents here the attack type data, and here is our density. Then we have our active versus idle time. There are two columns named one is idle time and another one is attack level. So we have used our attack level here as a hue, and we have used idle time and active time to create the column. We create the plot. Like in the x-axis, we have used the active time, and idle time we have used in the y-axis. And this is hued by the attack level. Like the blue one represents the normal traffic, and orange one represents the attack. Then we have another plot. And this is a box plot, and all of the box plot type you can just click here. Like this is a box plot, so it's mentioned over here. And for the scatter plot, this